Let's talk about the Wave Glider. Your current job is writing software for robotic submarines.
It's not a submarine.
Oh, what is it?
It's actually on the surface.
Oh, I apologize. I've been calling it. It's an
Yeah.
ocean robot.
Yeah. Yeah. So if you look me up on Vimeo, you'll find a video that sort of shows how it works. But a wave glider is essentially if you took a surfboard and a kayak and you kind of melded them together. And then there's this
Oh, that's cool.
umbilical, and then there's this umbilical cable that goes down about 20 feet. And there's this, oh, you've got it there.
Yeah.
Yeah, so there you see the wave glider, and then down below it there's this cable that links to this wing rack, sorry. And it's got these wings that go up and down. There's springs that dampen their motion. And so the wave glider is up in the ocean and up on the surface where it bounces up and down. The wing rack is down where the ocean is calm. And so it uses that differential to generate forward thrust, kind of the way that a whale's tail works. So the float is up in the waves, and we often tow instruments.
How interesting. And of course, the other reason to have something up in the waves is for solar power.
Yeah, so we get all of our electricity from the solar panels on top, and we get forward thrust from the wing rack.
Wow.
And both of those are totally infinite. The wave gliders can stay out in the ocean for months and months and months. And what's not really clear is that the device is incredibly robust. Our design point is a Category 5 hurricane. We're pretty much the only ocean-going thing that will happily go into hurricanes. And so the device is really a platform for instruments, and you can bolt onto it all kinds of things. And the tow bodies, in that animation there was a thing towed behind. Those often will contain things like acoustics. So one of the things that we do is marine protected area enforcement. So we can listen for poachers. And that's a pretty cool thing to do. But also, a lot of scientists will do things like measuring water chemistry, measuring ocean acidification. You can put like salinity sensors on them, and measure everything from like the melting of the Greenland ice caps to what's going on with ice in the Arctic. We do Arctic missions fairly frequently.
There's several hundred of these out there.
Yeah, and they work as weather stations. They can do pollution monitoring around oil rigs.
They're fully autonomous.
Yeah.
Wow.
So the software on board is a big bag of Java code, and there's a fairly sophisticated AI system in it that you give it a mission and it goes and does the mission. You can modify the mission on the fly over the satellite link, and some of the sensor data comes back over the satellite link, but the satellite link is slow and erratic, so the vessel has to be able to go for a long time without any communication with the shore. So if they're doing a long transit, we've got one right now just coming back from the Pitcairn Islands, and where we'd been doing fisheries enforcement with it. And it's, I don't know if you look on a map where Pitcairn Island is, but it's way in the South Pacific.
Isn't that where the Bounty mutineers got stuck?
Exactly.
Yeah.
It's
remote.
It's kind of an entertaining place, but
I bet.
rather than fly down there to install an instrument and deinstall it, we just have them swim home when it
That's so cool.
That one needs to have its hull scrubbed, so we're just having it swim home to Hawaii.
That is so cool.
And it takes a few weeks, but you just you just say, "Come home," and it comes home.
How do you
It's great.
avoid getting clobbered by other shipping traffic?
Well, that's where the AI part comes in. One of the more entertaining pieces of code I had to write a couple of years ago was, "Oh, you've actually got one of my demo simulations."
I kind of knew the answer before I asked the question.
Yeah, yeah.
So here's the Java code.
Yeah, so it's actually pretty good at going. You give it a sort of a mission plan, and the mission plan can have obstacles, and then sort of dynamic obstacles can sort of flow into that, and you can see where the wave glider has sort of deviated off to the side.
Right.
It avoids the ships, and it works its way around the obstacles, and tries to stay on the target line. It was told to go from between those dots that are kind of cyan colored, and it had those obstacles in the way.
And so just swim around them.
Yeah, it swims around them quite nicely, and it's able to sort out, like, if there are multiple ships that it has to dodge at the same time. It does all that. And writing that kind of code in C is really, really hard. You end up with data structures that are really hard to reclaim, inevitable memory leaks.
Yeah.
But it's pretty straightforward to do that kind of stuff in Java. So all of those sort of like control algorithms get much, much, much simpler when you've got a language like Java to work with. So yeah, it's been pretty entertaining, and it's been hard to get people to believe that it can actually do collision avoidance well. Some of the incidents have been pretty comical.
Boats trying to avoid it as it's avoiding the boat, and yeah.
Oh, we had
after
this,
you, Alphonse.
Really early on. The first time we launched a wave glider with the collision avoidance stuff in it, our engineering crews, a few days later, and I went to go pick up the wave glider because we needed to fuss with it, and I ended up with this phone call with a screaming boat crew because they couldn't pick it up.
Oh, because it was avoiding them.
It was avoiding them. They spent an hour trying to pick this thing up, and I said, just turn collision avoidance off.
You can't pick it up.
And we've had a couple of customers do the same thing.
That's hysterical.
Our operations center has gotten these like irate phone calls from customers, and it's like, damn it, don't you like it when software actually works?
It's nice.